Hello everybody, this is a continuation of the last video in which we actually, if you'll notice the parameters I have written over here, we were sketching parametric equations with specifically these definitions over here for x and for y. But in this video what we're going to attempt to do here is to eliminate the parameter, and just know that sometimes, as you noticed in the last two videos with graphing parametric equations, it can be definitely valuable, but at the same time it can be rather tedious because what we end up doing is allowing t, of course, being the independent variable, to wander, and then having to define x and y through that, and then graph those points, whereas we could just convert this into a simple equation in which it'd be a lot easier to graph with just respect to x and y. So this video is going to kind of discuss how we would go about doing so, okay? So you're going to notice here we have two parameters, and if we think about this, the name of the game here is eliminating the parameter t, and of course elimination is something we've done in the past with solving systems, and in this case the fact of the matter is, there being three variables, we can go ahead and necessarily eliminate one of them. And of course, the method we're going to use to do so is to solve for t in either actually one or both of these equations. If we had to solve for t in both equations, we could equate those two equations. Sorry for the redundancy there, because of the principle of transitivity. But the fact of the matter here is this: if we solve for t in one of these two equations, we can necessarily plug that value into the other equation and just be left with x and y terms, okay? That's going to be our ambition here, and we're going to go ahead and start by solving for t in the second equation. And you know what? There's nothing wrong with solving for t in the first equation. It's just more convenient in this case to solve for t in the second equation, because all we have to do necessarily in this situation is, you notice here, we'll multiply by 2 on both sides. So we say these 2's would necessarily cancel out, and here's what we're left with. We say, okay, so 2y must be equal to t. Now this is the thing that we want to keep in our pockets, because what we're going to end up doing is we're going to plug this into the other parametric, half of the parametric equation up top here. But the other half there was x, of course, defined as being t squared minus 4. And the nice thing here is this: now that we've solved for t with respect to y, we can go ahead and take this 2y and substitute it in for our t here. So now we've got this. We've got x is equal to t squared minus 4. And in this case, t is equal to 2y. So now, going ahead and sending that exponent through here, we say, we've got 4y squared minus 4. And this is actually very easy to see at this point that we're dealing with a parabola that opens sideways, because our y component is the thing that's being squared here. And of course, we could go through and use a directrix and a focus and go ahead and graph this with its vertex in standard form. But right now, you have to take my word for it here. This is the last graph we made in the last video. So anyways, you know what? I want to attempt this again, but with something a little bit more complex, because that was kind of trivial. So what we're going to do is, let's go ahead and generate a new set of parameters. What we'll do is we'll say, like, x is equal to 1 over radical t, how about t plus 1? And then we'll define y here as being, I don't know, t over t plus 1. Okay, t over t plus 1. Okay, now keep in mind what we had mentioned previously is what we're trying to do here is solve for t in just one of these two equations here. So what I'm going to do is I'm going to go ahead and opt to go with this equation on the left here, because I see a unique opportunity to eliminate a radical from our midst here. So we say, okay, if we were to take this equation right here and square both sides, okay, we'd end up with x squared on the left, but the nice thing is we'd have 1 squared on top, which is just 1, and then radical t plus 1 on bottom squared would eliminate that radical, and we have x squared is equal to 1 over t plus 1. Now the nice thing about this is we can go ahead and take this equation right here, dun, 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 and we can imply a few things about it. Actually, what we were trying to do, remember, is solve for t. So I'm going to do a little bit of sleight of hand here, and if I lose you, I'm sorry. Go ahead and pause the video and rewind it maybe, but fact of the matter is this: t is in the denominator, and one effective method for getting it up top here with a proportion is that we can just go ahead and reciprocate these two proportions. So we say if two things are equal, then their reciprocals must be equal. And now I just realized the mistake I made here. We say t plus 1 is now on top, and we've got 1 on bottom. But the fact of the matter is we could just express this in this a unique opportunity here. We say 1 over x squared is equal to t plus 1. And so what we'll do is go ahead and kick this loose term here. We say, okay, so 1 over x squared minus 1 is equal to t. So now we'll keep this in our pockets, because what we're going to do is we're going to go ahead and substitute this in for t, but in the other equation, okay? So I'm going to try and make some room here, a little bubble. Hopefully that'll work for us. But we say, okay, so let's bring down this y equation. Of course, we had y was equal to t over t plus 1. But see, we have some information about t now, okay? So we're going to go ahead and say y is equal to t. And in this case, we're substituting in for t. We're substituting in 1 over x squared minus 1. And down here, of course, in for t, the same value that we solved for, minus 1. And this is plus 1. Okay? So, you know, a few things going on here. As a matter of fact, what we could do is we could necessarily take the top and the bottom. And you know, I want to, you know, realize this at this point. Those two things you cancel out. But we could take the top and bottom and multiply everything through by x squared, which in this case we would refer to as the least common denominator. So multiplying by x squared on top and bottom would actually do us a favor in the sense that it would eliminate this 1 over x squared on the bottom, and we have y is equal to something over 1, which is extremely convenient. But we say on top here, we have necessarily this x squared times 1 over x squared, or anything times its reciprocal is 1, minus 1 times x squared is this, okay? So we end up with this equation y equals 1 minus x squared, which is really, really actually easy to point out that this is a parabola that opens downward with a kind of a normal gap there and has a y-intercept of 1, which is a lot easier than looking at its parametric form. So enjoy.